programs, we're back for another LeetCode adventure. Today we're going to be tackling number 2, add 2 numbers. This is a medium problem, and let's go ahead and get right into it. You are given 2 non-empty linked lists representing 2 non-negative integers. The digits are stored in reverse order, and each of their nodes contains a single digit. Add the 2 numbers and return the sum as a linked list. You may assume the 2 numbers do not contain any leading 0, except the number 0 itself. All right. So they show us here an example of the number 342, but it's written backwards, so 243, and 465, so 564. And if you add them together, you get 2 and 5 is 7, 4 and 6 is 0, and 3 and 4 is 8. Now, why is 3 and 4 8? Because 6 and 4 was 0, and you carry your 1. So that's basically the main thing you got to worry about here is your carry number and traversing through. Excuse me. Now, there are a few ways we can handle this. We could do this with recursion. Recursion will get us through the same problem relatively quickly. Basically, you just send your carry into the function call, and you get each node in the function call. You add them, you move on to the next node. The other way would be iterative approach. That will go through and do the same thing as your recursion one, but in a while loop or for loop, depending on what information you have. And you'll just still be looking at each node at a time and moving through and handling your carry value. Let's see here. The number of nodes in each linked list is from 1 to 100. So each linked list has to have at least 1 node and won't have more than 100 nodes. And the values are from 0 to 9. So let's see here. It is guaranteed that the list represents a number that does not have leading zeros. So you won't see like 0, 0, 2, 0 for 20. It'll always be 2, 0. Okay. That's perfectly fine. Let's go ahead and jump into the code here. We will see what they give us for code here. So, we got this little thing going on. Okay, so let's change the brackets here first. That's just a pet peeve of mine. I like them to be on the same line. Or on a new line. Sorry, not the same line. Okay, so let's see. A list node, they're deriving clone, debug, equal, partial. We're in Rust, by the way, for anybody that's wondering. We might have to fight the borrow checker a little bit here and there, but that's the language we're going to be using. Let's see here. So we have a list node. It's got a value, and it's got its next. And you can create a new list node by passing in a value and return it. Okay. Now the next is an option box list node, and our values passed in for our lists are option box list nodes. So they're doing it as a linked list instead of like a vector. Linked lists in Rust are a bit tedious, mostly owing to the whole borrow checker and its requirements. It makes it really difficult in the linked list to say, hey, who owns what, who owns what. But you'll see that they're doing the owning here by putting the heap allocation of a list node into that list node. So each list node will own the next list node. And then they have an option here to say whether there is a list node next or there's not a next list node, because that'll either be some or none. Where in C, you would just have like a pointer to next, and you would set it to null. But the problem is that there's nothing in C that specifically says, hey, this is either null or something. In fact, half the time, null is just 0. And that can become problematic. This makes you have to know whether it's some or none. And that's just traits in Rust. Okay, so let's get to it. How are we going to solve this? Well, we're basically just going to go through one by one. So let's just do the for loop. We need to have a return list at the end. All right, so we're going to have to create a list. Let's go ahead and let's see here. We're probably going to have to move the head of our list. And that's just going to be one of these box list node things. So box list node. And we'll set that equal to a new box of a new list node. Okay, so that's the head of our list. Let's keep a reference to that because we don't want to lose the head of our list and not be able to return it if we move the head, because there's no way to go back here. We have no previous nodes in our list nodes. So we're just going to go ahead and create a tail. This tail is going to probably move. And this will be a reference to our head. So we'll go ahead and say that's a reference to a box list node. And we'll bring back mutability after we figure out how we're going to use some of this. It might be that we need that box list node to be a mutable one, so we can change things inside the box list node, like the value. But for now, we're just saying here that we're going to be able to change what tail is pointing to, and we'll see how that goes. We're probably going to need to be a mutable box list node so we can change the values of it, though. Okay. Now, we're in Rust land, and these options and boxes are usually a little bit of a headache. We need to get the value out of the option, but we don't want to borrow it. So to do that, we do a we're just going to call list 1 and list 2 left and right. So list 1 will be left. So we'll go ahead and take list 1, and we're going to get as deref, right? Now this is going to return a, if I have this right, an option and box list node. If I have that right. And then we're just going to return none as our default. That way I can go ahead and just check. I think I have that right, but we'll see. Mixed mask closing delimiters. Let's see where it's barking. Two numbers. Seem to match delimiters to me. I'm missing a superfish. Oh, because that needs to not be. There we go. Parentheses. Okay. So let's go and see what we get here. Expected option and box list node found option and list node. Oh, okay. So it unboxes it even. Okay, that's nice. So option and list node. Okay. There we go. So we're going to get that dereferenced. And we'll do the same thing for the right. So let right be in option. Now, you don't have to put these types here. It will figure them out for you and just auto-assign them. But I like to be explicit. L2 as a deref. Okay. So that gets us our left and our right, right? Now, we need to go through the list for each left and right, and we're going to add them up. So we're going to have a carry value. So let's go ahead and let carry. Now, this one's going to change a bunch. I know that. Let carry, and that can be an I32 because we're adding I32s, if I remember correctly. Yeah, value of an I32. Equal to 0. And then we need to add the nodes up. So let sum be an I32. And we'll set that equal to 0. Okay. So then we have these option list nodes. So what we're going to do is we're going to say that if there's something in the left, like it's sum, if there's nothing, we don't worry about it. But if there's something there, we say add it into our sum. So if let sum, we'll just say node equal left, right? And then that will be sum plus equals node.val. Do we have a better word for left and right? Like, there's got to be something with operands here. So let's see. Addition, operands. Take two numbers called add-ins as operands to work on. They're both called add-ins, though. We'll just go with left and right. Okay. So then we're going to take our left, and we're just going to move it to the next node because we got our answer out of this node that we need. And we already are working with the node, so we can just say that our left one is now going to move to node dot next, right? Let me do the same thing for the right. Oh wait, we got these options. That's right. We dereferenced it as above, so we'll do it as below. As deref. As above, so below. Okay. So that handles adding and moving on from the left. That's 1, 2, 3, 4, 5. So take those and put them here. And we're just going to change this to right. And we'll do the same thing with the right. Boom. Okay, so now we've added them. Everything's good there, right? So now we just need to go through and if we had a carry value, want to add that. So sum plus equals the carry value, right? And then we can set our carry value to 0 because we've used it. And then we'll set our carry value to we could do this with a loop. So we could go ahead and just say that while the sum is greater than 9, keep subtracting 10 and then add 1 to the carry. Or because we know that it's only ever going to be 9 plus 9, you're only ever going to get 1 for your carry value. Because even if it was 9 plus 9, which is 18 for the one previous, that'll be a carry of 1, which gives you 9 plus 9 plus 1, which is 19, which will still only ever give you a carry value of 1. So we should be able to just say if sum is greater than 9, subtract it once, add the carry. But we're just going to do the while loop because it won't add much to it. Well, we want to get top speed on this. Okay, we'll go ahead and just do it as the minus. So let's see here. Carry equals 0 will now become if sum is greater than 9, then sum minus equals 10, and and return 1. Else, return 0. Okay, so that should put the 1 into the carry, and this should put the 0 into the carry if sum is less than or equal to 9. Okay. Now, we can... This should add together 1 and move on to the next node. Let's see here. Let's run that and just see what we get. No, we're never printing out what we... Okay, well, we gotta fix this anyways. Instead of make this binding mutable. Yeah, so left and right need to be mutable. Okay. Mutable. That looks great. Okay, so... But we're not printing anything out, so we don't know what we're getting. So let's go ahead and just print out what our sum is. So print line, we'll say sum, and we'll say carry, and you're going to get sum and carry. Okay, so go ahead and run that. That'll give us our printout there, and we can move on. So sum is 7, carry is 0. 2 and 5. Great. That looks really good. What about for another test case of 0 and 0? Sum is 0, carry 0. Great. 3. 9 and 9. Sum is 8, carry is 1. Perfect. Okay, so now we've done it, once. Now we can go through and do it again. So we've moved our left and our right nodes already, right? So now we just need to put this into some kind of a loop. So while left dot is sum or right dot is sum. So while there's either a left or a right value, go ahead and do our loop. So we go ahead and pop all these over. Okay. All right, so now while we have left and right values, we're going to keep doing it. Let's see how that does. That should move us through our array so that we're getting multiple printouts now. So sum is 7, carry is 0. Sum is 7, carry is 1. Sum is 5, carry is 1. Well, that's not right. That one there is telling me that something is not right with our sum. Oh, our sum is up here. Okay. Well, it would help if our sum gets set back to 0 at the beginning of every loop. Carry can stay through the loops, but sum just needs to be 0. Okay. That should reset that. So sum is 7, carry of 0. Sum is 0, carry of 1, so 10, okay. Sum is 8, carry of 0. Perfect. All right, then let's see case 2. Sum is 0, carry is 0. Good. And then case 3, we should end up with 8, carry 1, 9, carry 1, 9, carry 1, 9, carry 1, 0, carry 1. We never get rid of our carry 1. Okay, so we got to add in to get rid of the carry 1 at the end. So right before the end, if carry is greater than 0, then and 1. So for now, we'll do this. Okay. Sum is 1, and carry 0. And we don't need to carry in some values there then. Okay, and run that. So now that case should be, that was case 3. Yeah, there's our 1, and we finally get our carry down to 0. Okay. That looks great. That looks perfect. Okay. So now all we have to do is go through and turn this into a linked list return instead. So we'll go do that down here. Get rid of this print line. And now we have our tail, right, and our head. So our tail and our head are saying that the tail's going to move through the list. The head's just going to be there. So we just need to worry about tail.next equals our value. Some box of our list node, right? That's going to be sum. Whew, that's a big one. And then we move tail to our tail next dot. What do we do? As deref? No, that's not right. That's not right. Let's see. We need the next. Maybe it is sdref. Okay, let's see how that runs. Mismatch types. Expect to do this type. Okay. So Tails looking for an and box list node. But what we get was an option list node. So we need an and box list node. Can we take it as a mutable unwrap? Because if we unwrap the maybe we just do unwrap. Maybe we don't need the mutable. So if we unwrap the option, that should give us the box list node, right? Yep, that gets us box list node, and then we just need the reference to it. Yeah, that's what I thought. We need to make this a mutable thing. Okay. Because we got to assign to it. So we're going to go ahead and do as they say and make that mutt. Do we need a mutt there? I think we do. But then that tells us that we need this as a mutt. Okay. As a mutable value. And we go through. Dun, 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 dun. Okay. Oh, we don't need the reference. So now you got 2 references. Okay. And there we have it. But we're not returning it. And we still have to add this one in. Okay, so this one down here, we just need to say that this line up here goes down here, and we just do carry. And then down here, we'll just return head. All right, run it. Oh, sorry. Some head. Okay, well, we're close. Real close. We gotta take off our dummy head part, so we'll just do head dot next. And that should solve. Oh, okay. Now we don't need the sum because we're already an option stored in. Okay. Head dot next. Return it. And there we have those solved. Okay, cool. So we walked on through. Now we're going to go through and we're going to get rid of our print lines. Just the one? I thought we had another one there. Oh, I guess I got rid of it when I did this. All right, so we will run there. And we should see exactly like they expect for our output. Cool. Awesome. All right, well, let's submit it and see what we get. And there you have it. So our runtime, incredibly fast in our for loop. Our memory is pretty low. Somebody got a little bit lower. But, we're doing pretty good. Is there a way to get it faster or a lower memory footprint? Maybe. Let's take a look, see what they did. See if we can see what it is. Just off the off what they have. They have an answer vector? Putting everything into the vector, then they loop through the vector and add it all in. Okay, so what they're doing is they're pushing it all into a vector, each answer. And then they loop through the vector and add nodes to the vector. Because they're going through the vector in reverse. Interesting. That way their last node they get would be their current node, and they return that. Okay, so that works. But they should have a bigger memory footprint than me because they have a whole vector. Huh. And they've got 3 whole vectors. How does that not have a bigger memory footprint? There's got to be some funky Rust thing going on there, but we don't have time to look into that today. We solved it. We got a pretty decent answer there. So thanks for joining me, and I'll see you next time. End of line.